first one of those ideas is design. When we think about design in a formal sense, analysis, synthesis, and evaluation, there's not very much stuff out there that's designed. Something like 2% of American homes are designed by architects. If we think about design in a less formal sense, independent decisions, incremental actions made over a long period of time, things that we probably say just happen, then much of the world, much of the United States is designed, is altered in some way. Relative to buildings, gravity here. Relative to buildings, we spend something like 90% of our time in buildings. Even a beautiful day like today, I bet most of us will spend at least 90% of our time in buildings. Thank goodness we don't have too many real long commutes here. Buildings last many years. We don't have to worry too much about the energy efficiency of 5-year-old computers or 30-year-old automobiles. We get rid of those things. Buildings, 50 years, 100 years. Some parts of the country and the world, several hundred years. So those things are around for a long time. Buildings use about half of the U.S. energy. We get pretty excited about fuel-efficient automobiles or fuel-inefficient pickup trucks or whatever it is. The entire transportation sector uses something like 1/4 of the energy. Buildings, very close to half. Some in construction, a lot of it in operation. There are lots of dandy references that I point my architecture students to. One written by Norbert Lechner. Anyway, he talks about a 3-tier model, kind of an ugly diagram, but a 3-tier model where some of the basic things in his first tier, the building shape, orientation, size, those where the windows are, those real basic sorts of things. Poor decisions at this point can easily double or triple the size of the equipment and the energy that's used. Good decisions at that point can reduce energy use as much as 60%. A few other things, passive heating and purely passive cooling and some daylighting systems and so on, perhaps another 20%. So at this architectural level, as much as 80% of typical energy can be saved. Second idea is greenwash. Maybe you're familiar with that term. Whitewash covers up a superficial coat of paint, thin paint that covers up who knows what kinds of errors. Greenwash is certainly thrown around a lot these days by an awful lot of manufacturers and advertisers. Sometimes there really are some green attributes, but sometimes because of lax enforcement in this country, there's some problems. Fibbing, perhaps, is putting it mildly. Perhaps leading to consumer skepticism about all kinds of green claims. So there's some questions here. For instance, you've probably seen the recent TV commercial. Ever Ready contains 4% recycled batteries. Well, I suppose 4% is better than 0%, but that's I don't get too excited about that. Or maybe you've seen a Nissan Leaf, pure electric car. On the back, there's a badge that says 0 emissions. Well, I suppose 0 emissions right there at the car, but quite a few emissions someplace else. I kind of leave that part of the story. I'll say a little bit more about LEED, but a LEED building, even platinum level LEED building, typically only 20 or maybe 30% less energy than some others. Recycling, and I put a question mark there. I have some questions. I'm probably not making any friends with this. I think a lot of it is just feel good and not accomplish too much. This weekend in the New York Times, they had a pretty interesting article that talked about some of the positive things about recycling, but some negative sorts of things as well. Some of these recycling activities actually use more energy than they save. Third big idea, less bad. I owe William McDonough for this particular thing. A lot of times we talk about this and that or the other thing and say, oh, well, this is good for the environment. There might be some things that are good for the environment, but a lot of times we're really talking about something that's less bad, less poisoning, or slower killing, or something like that. So let's use that terminology. I don't think any automobile designers here, so I won't offend them. 20 miles per gallon, 40 miles per gallon, maybe an electric car, 100 miles per gallon equivalent. Some questions about how you measure that equivalency. But anyway, oh well, 40 miles per gallon, that's good for the environment. Well, no, it's not. It's just less bad. It's still making carbon and so on and so forth. So let's get the terminology correct. Living Future Institute is an interesting group, and they're really posing some questions, asking that question about what good really looks like. I have some notions of that here on a spectrum of buildings from real bad less bad to actually good. Texas, some of the new buildings at Texas Tech are probably in this realm or around Lubbock, still clearly in the negative category. I'm not used to thinking about regenerative buildings that create pure air or purify water. Maybe some of my colleagues in natural resources and some other places can think about that. There is an architect that has addressed that particular thing. Supply and demand, of course, we're familiar with those terms. Most people, when they think about climate change and global warming, immediately think about renewable energy from sun and wind and so on. If we think a little bit farther, we can start thinking about building efficiency as an example of that. And according to Norbert Lechner, again, easiest, quickest, least expensive way to fight global warming is reducing the demand for some efficient buildings and other sorts of things. Lechner talks about, and he says perhaps at a 5-to-1 cost effectiveness ratio, efficiency 5 times more effective than money spent in generation. Efficiency is the low-hanging fruit. I guess that's the low-hanging fruit, and photovoltaic and wind and so on a little bit higher up. If we think about supply and demand in some ways, supply, there's lots of gizmos. We sure like shiny gizmos. It's glamorous, easy to photograph. The idea of the magic bullet, oh, if we just did such and such, everything would be fine. We sure like that idea. If we look at the demand side, it's a little more complicated. The process is a lot harder to think about. It's ordinary. A lot of times, twice as much insulation in a wall. It's covered up. You can't see it. Even if you saw it, it wouldn't be very dramatic to look at more of that. The new issue of the November 2015 issue of National Geographic, the climate issue, seems to take that the approach to it. Boy, that sure is glamorous. That sure is shiny. That's high tech. I'm pretty excited about that particular thing. So just in case you didn't get that point. That is a generator, solar mirrors, 10,000 mirrors shining at a tower that boils water and makes some electricity. You didn't get the point. Reduce demand, reduce demand, reduce demand. Wicked problems. Any Berkeley graduates in here? No Berkeley at all? I know there's a few on campus. Oh, okay. I was fortunate enough to be at Berkeley in the late 70s, and Horst Riddle had already retired from the architecture faculty, but a few years, his shadow was still around, and he talked about wicked problems. Wicked in the sense of resistance to resolution, complex interdependencies, and so on. There are aspects of design projects that I face in architecture that at least some of those are considered wicked problems. Interesting paper identifying climate change as a super wicked problem. Affects all of us, but there isn't any authority, so on and so forth. Interesting paper published some years ago. Notion of competing stakeholders, clients, users, community, and so on. In the case of users, if we were talking about an academic building perhaps on campus, we'd be talking about faculty, students, staff. Sometimes their interests are completely the opposite. Regulatory bodies like code officials and so on. And values, even when we're talking about budget, first cost, operating cost, maintenance costs, certain kind of facilities, we talk about resale, schedule, safety, comfort. That seems to be important to a lot of my students these days. Aesthetics, function, meaning. The university seems to be spending lots of time and money dealing with some kind of notion of the past, some kind of, I think it's phony sentimentality myself. Anyway, some issues, all of these could be elaborated in great detail. The future, we can't even get into that. Notion of extended timeline when we're talking about buildings. Of course, the useful life of the building, we think about that. Day one, the building opens, the pictures are taken. Actually, architects like to take pictures on day 0 before those pesky users get into the building and do that. Anybody that thinks even a little bit about buildings, you think about operating energy, maintenance materials. But these days, we need to think about where those materials come from, the embodied energy in that, the environmental costs of extraction process, and so on. And the post-life of the building. Now, if the building's really flexible, it can be adapted to some other kinds of uses, that's probably desirable. Many years out of things. Recycled materials, so on and so forth. That steel in, that steel in reinforced concrete, it is recyclable. How do you get those steel rebars out of that steel? The building. Notion of a net zero, net negative, net zero, net positive. Okay, ought to be pretty simple. Turns out there's a lot of different ways to think about net zero. I'm pretty careful when I use that term. On the grid, off the grid. Off the grid is extraordinarily difficult to do. However, 100 years ago, everything was off the grid. There wasn't a grid to speak of at that time. People's expectations of being too cold and too hot and too dark and so on and so forth had probably changed. That's a whole other sort of thing. There's something called building dashboards. Here's one from the Brower Center looking at solar and electricity production, grid production, and so on. Different time frames, all kinds of things. Cornell has a lot of buildings with building dashboards that you can access online. There's several sustainability rating systems. LEED is just one of them. That's by far the most famous one. There's some criticism of LEED for a variety of reasons. There's some other systems also out there. LEED is even split up into 5 different systems, really: building design and construction, interior design, homes, for instance. And it looks at a whole variety of different things, attempting to put some metrics to this. Gets complicated, of course. The latest version 4. There's still a lot of emphasis on energy and atmosphere. About 30% of the points come from that. Those sorts of things. Let me end with the notion of passive survivability. It turns out that a lot of things that are good for do for buildings dealing with passive heating and cooling and lighting and so on are real valuable in the case of a natural disaster and the building is forced off the grid. If a tornado went through a campus this afternoon, I'm confident this structure would stand up, but we'd be in trouble without heating and cooling and electricity for lighting in this particular room. Very briefly, these ideas have been around. Some of these ideas have been around for a long time. There's a dandy book that traces it back 2,500 years. I'd like to point to the architecture of the building. Opened in 1971. Typical building of that time. Used a dual duct heating system where heat comes through one duct, cold through the other duct all the time, and then is mixed at the room depending upon what the need is. Enormous amount of energy goes into that. Some fixed glazing, can't open the windows, lots of lighting. Well, I wasn't around in 1971, but the building opened. The energy crisis in 1973, all of a sudden, so it got 2 years where they didn't worry about these things. After 1973, after 1979, all of a sudden these became real issues. Some of us remember those things. Lots of problems. So it was pretty great for a couple of years, I guess. We've been fighting it ever since. Anyway, thank you for your attention. I invite you to take a look at this webpage. If you drill down through architecture, faculty, Perl, PPR, you can find it. Actually click on some of these links, or just TTU Perl, P-E-R-L. I'll pop up there. Questions?
So one thing I haven't seen here at all is underground buildings, which seem to fit a lot of the profile you described. Obviously, we get issues with how deep we can dig before the water starts bubbling up and everything, but is that just not an option anywhere in Lubbock, anywhere on campus?
Well, I happen to have been involved with for many years, a cooling tube project where the air circulates underground to lose its temperature and then is used. And people aren't underground, but the air is. I know something about that. I'd be delighted to talk to you about that. There are some problems, as you can imagine. Legionnaire's disease, remember that? Wow, let's blow moist air in over cool stuff and then breathe it. That's one of the problems. There are solutions to that. There's some other things. There's not much underground activity going on any place in the U.S. these days. There was a wild enthusiasm 20 years ago or so. Not much now. There's some reasons for that.
So I found it interesting how it's the buildings account for almost twice as much as the car emissions.
Yes.
Of that 48%.
Of the entire transportation sector.
Yeah.
Not just private cars.
Yeah. Of the 48%, how much of that is accounts for post-completion?
About 40% of it. Almost all of it. Most of it is from operating buildings.
And
Some of it is in the construction, of course.
yeah, so, and is most of that 40% due to heating and cooling?
Heating, cooling, and lighting. Lighting is kind of a double whammy because we're generating heat with those lights. LEDs change that a little bit, fluorescence a little bit, but tungsten makes a lot of heat that you have to get rid of then. There's so many variables to really answer that. It depends upon the building, the climate, and the usage pattern. Obviously, at night, there's going to be some electric lights in the buildings.
50, 60 years ago, architects in Venezuela, Brazil, developed new ways of designing buildings so that you had these tiles or structures that would jet out from the building. We have this in the main library in front of the tiles that in fact absorb some of the light heat. To what extent are tropical architects, if you will, in Latin America, India, Africa, rethinking the way buildings should be designed because of some of these other factors?
Well, certainly there are activities. For a while, we talked about the international style. 1950s architects were doing glass boxes all over the world. And as long as you could afford to run those, I suppose they were moderately comfortable. Of course, we can't afford to run those anymore, problems with the carpet and so on and so forth. So there's some work being done in a variety of different places. A lot of the United States, we have to worry about heating and cooling. So there's some interesting challenges. I usually try to propose design projects to students that deal with heating and cooling, not just one or the other. Near the equator where the sun shines on the north and the south side of buildings, that creates some interesting situations that I'm not very used to dealing with. Thank you. Oh.
I have a comment as much as anything. The conservation forms that we have sort of, we can live pretty much the way we are if we just live smarter. Almost never sort of, as you're pointing out, pencil out 40 or 50 years from now. One of the things that is difficult we can extend the retrofitting a building that was built badly to retrofitting society that was built badly. And retrofitting is very, very expensive. We've watched energy efficiency in homes, and the first thing that happens, you get about 20% efficiency in homes, and then the home says, okay, I can build it 20% bigger now, which is in fact what's happening. I guess the comment is more, when are we going to be serious that we have to just live?
You tell me. Since the 1950s, American homes are about 2.5 times as large with fewer children.
Yeah. Yeah.
That should be the topic of the next seminar.
Yeah.
Thank you very much.